Good morning, everyone. Hello and welcome to today's webinar, Optical LAN Testing Recommendations. My name is Chad Hines, Vice Chair of APOLAN's Technology Committee, and I'll be your moderator today. To begin, let's review a few housekeeping items. Audio has been muted today for everyone except our speakers. For submitting your questions, please use the questions feature on your screen throughout the presentation. We'll do our best to answer as many questions as possible during the presentation, as well as we'll give some time afterward to answer. And the earlier you submit, the better we'll be able to manage our time. Please take a moment to review APOLAN's antitrust and no solicitation policy that are on the screen. At least they'll be on the screen here in a minute. For our overview description, accepted methods for testing and certification of optical LAN cabling systems. Some learning objectives, understand optical budgets for optical LANs. Learn common issues in troubleshooting optical LAN cabling. Know accepted methods for testing and certification. All right, now please take a moment to review APOLAN's antitrust and no solicitation policy that are on the screen now. And our legal disclaimer. All right. Before introducing our presenters, we'd like to learn a little bit about you. Please select or enter your responses to a few polling questions that we have in the pop-up window on your screen now. All right, getting to know you. Where are you joining from? The country, maybe the state within the United States? Give everybody a moment to type something in there.
I apologize. I guess
right.
it's not showing the answers.
That's okay. It looks like it recorded the results. So we'll move on to the next question. All right, here we go. What type of company do you work for or own? Like to see what type of field you guys are in. Oh, there we go. That one showed our results. Thank you, Brianne. All right, looks like we got a bit of consultants in here, some designers, some general contractors, integrators. This will be a good presentation for all of you. Then for our last question, we'd like to know what your primary industry is. What vertical do you guys work in? Some of you probably, as myself, work in all of them or as many as you can, right? Where the work takes us. All right. Looks like we got a lot of people who work in the education industry. That's definitely my largest customer. Some mixed use, office, and other. All right, great. Well, thank you everyone for taking the time on the polling questions. We like to know who we're speaking with. Helps with the flow of how we present these webinars. So let's meet who our presenters are. Um, as I mentioned before, I'm your moderator. I'm a sales engineer with IT Connect, and I'm the vice chair of APOLAN's Technology Committee. Our presenters are Matt Miller and Scott McIsaac. I can turn it over to Matt if you'd like to tell us about yourself.
Yeah, thanks, Chad. Yeah, my name is Matt Miller. I'm the networks leader for AECOM's Technology Solutions division, and with APOLAN, I serve as the committee chair for the Technology Committee. So with that, I think we can get started on our presentation. So move forward here. Oops, there we go. So we're going to talk about connectors, cleaning, and link budgets first, and then we'll get into the meat of it, where Scott can talk about our actual testing and certification of the fiber. He's quite the expert on those things. So getting started, SCAPC is our default standard connector in a PON network. Doesn't mean we have to use it necessarily, but we're going to see that all of our ONTs out in the field are going to have an SCAPC connector, and so that's often what we see as the connector on our infrastructure throughout, right? On our cables, on our bulkheads, on our LGXs, those are all going to have SCAPC typically. The reason we do that is because APC connectors reduce back reflectance. And if we're doing things such as injecting video onto our system, that's especially important because video comes off at a very high power. And so reflectance back at the source can be problematic for those devices. So just as a comparison to see what those look like, what we're typically seeing in our older networks is UPC, but not just in PON, but in a lot of other applications, we're seeing APC become the de facto standard. It is a superior connector or polish type as we speak about it because of that reduction in back reflectance. So you can see it's got the angled offset in how the fibers interlock with one another as they're plugged in. So what that results in is our lower, or I should say higher back reflectance. We actually want a higher loss of back reflectance when we're using the APC polish versus our UPC or PC. So more attenuation in the back reflectance is a good thing. That means that we're getting less signal reflected back at the transmission source. So to visually describe that to you, what we're looking at here is a polished connector, or UPC, ultra polished connector, not angled versus an APC, which is angled, that has that 8-degree offset, as we can see on the bottom portion of the slide there. So when we send a signal down an unmated connector, meaning that's just a connector that's hanging freely, not plugged into anything else, on the UPC connector, we're going to see a reflectance loss of about 14.7 dB. That means some of that signal goes through to the end destination, but some of that is actually sent back. So we see a reflection loss or reflectance loss of 14.7 dB approximately. Now on an APC, that reflection hits an angled offset, right? And so most of the reflection is sent into the cladding of the fiber where it's dissipated. So we will typically see greater than 60 dB of loss on our back reflectance. And remember, more loss is good, right? We want as much loss as possible in the back reflectance. So you can see the 60 dB is far superior to the 14.7 dB. In a mated connection where they're actually plugged into each other, we're going to see similar results. The reflectance loss being 50 to 55 dB for UPC, so it's improved over unmated, but we're still going to see the superior return loss, again, a greater return loss on the APC. So that's why we use APC in our PON networks. So let's jump into another quick poll here on cleaning. I'm kind of curious for our folks that have joined us today, what percentage of fiber network problems are related to cleaning, do you think? Is it 20%, 50%, or 80%? So of all the problems that we encounter in fiber networks, what percentage of those do you think are related to cleaning? 20, 50, or 80? And we get the results from the manufacturers and from our folks out in the field that are troubleshooting these things. The manufacturers often get equipment back and they'll test it in the field or test it in their labs to understand what happened, right? Why did it fail? So let's see what we got for results. Okay, look at that. So some of you said 50%, but most of you said 80%, and 80% is the correct answer. So kudos to those that answered that, and it's good to hear that awareness of how many problems are related to cleaning. So our next slide just reinforces that. According to NTT and many others, like I said, our manufacturers would certainly attest to this as well, because about 80% of the ONTs that come back to the manufacturer aren't actually hardware failures. They're just due to dirty connectors. So that reinforces how important this is, right? So when we look at a single mode fiber, that 8.3 micron core that carries the light from one end to the other, we can see what a particulate does there, right? The smaller the core, the more a small particulate is able to block that light as it traverses the fiber, right? So getting a small piece of debris or oil in there can have a large effect on the light making it through. So some common contaminants that we see in this industry and across all of fiber, right? Dust particles, right? Those are kind of the obvious ones that we all think about, right? Uncapped fiber, attracting dust particles, but it's really the lotions and the fingerprints that can really have a dramatic effect, because the lotions and the oils on our fingers will attract those other things, the dust particles and debris. So getting those things on the end face then attracts the other pieces that can cause even more contamination on the end of the fiber. Even alcohol residue can be an issue, right? So improper cleaning can actually cause contamination of the end face as well. So those are all things we want to avoid. And of course, the worst part about it is that once you've dirtied that connector and you then connect it, it will start to migrate. And it will transfer from one end to the other. So if I have a dirty fiber on one end and I then plug it into another device or another fiber, that contaminant will transfer from one to the other. So now I've got two dirty end faces as a result of what I've done. It will also migrate. So you get that contaminant on the end face of the fiber, then you made it you plug it into something, an ONT or a fiber bulkhead, it will then migrate around the ferrule, right, around the end face. So every time you click it in, it's going to migrate and migrate again. And unfortunately, it tends to move toward the middle of the ferrule. So your problems will actually continue to increase as you plug that connector in more and more times. So we want to avoid that problem in the first place with cleaning, right? So another easy poll here for us once again. How many of you inspect your fiber every time before connection? Be honest now, okay? Every time, do you inspect that fiber before you connect it? See if we can get that poll to come up here. So we'll just give everybody a few seconds to complete this one. This is a simple one, but just curious, right? You know what? I'll even admit I don't do it every single time. There, I said it. So you can answer honestly as well. It's okay. All right, so we'll give it just a few more seconds. And our results. Okay, so 60-40 on whether folks are inspecting their fiber. And maybe it helped that I admitted, right? So we're all in the same boat there. At least 60% of us are in the same boat. Okay, so moving on. Best practices for inspection. So as we know, cleaning may not be enough, or it may be unnecessary, right? So inspecting that fiber is the best way to do that, right? So we want to look and see when we inspect that fiber, is it damaged? If so, then that fiber needs to be replaced. Or is it dirty? And if so, it should be cleaned, right? And then once that inspection shows that it's clean and undamaged, then we can pass and move on to connecting that. So let's move on to link budget, right? And I won't include all our dirt in our link budget, right? We're going to assume we have nice clean connectors as we plug all of this together. So let's talk about the things that fit into our optical link budget. And most importantly, in a passive optical network, we have this unique device called a splitter, right? And that can be anywhere from a 1x2 all the way up to a 1x32 splitter. So if you're not familiar with what the splitter does and how it works, we have plenty of other webinars on APOLAN that can explain that. But in terms of budgeting, we want to account for a 3 dB loss for each 1x2 split. And we have a link budget table for you in a little bit here that shows each splitter and what that accounts for. But essentially, you know, your 1x2 splitter just has a single 1x2 split, of course, but a 1x4 is a series of cascaded splits, right? It's a 1x2 and then another 1x2 to get us a total of 4 outputs. So that would have about 6 dB of loss, plus a little bit more to accommodate for connectors and whatnot. Then we want to refer to our ANSI TIA values for our other pieces. So we want to budget for 0.75 dB per mated pair, right, for every connector in the system that connects into something else. And then we're using single mode fiber, of course. So for every kilometer of distance, we're going to accommodate for half a dB of loss for that single mode fiber cable. Now, a lot of us, we're talking about the LAN environment. So often that's not much of a factor, right? We're usually less than a kilometer. But that doesn't mean always, right? Sometimes we're going across campuses or large swaths of land. So we need to accommodate for distance as well. And our bend insensitive cable can certainly be helpful on those things, especially if we're talking about long distances. So looking at those tables that I referred to, we can see on the right side the attenuation of a few different aspects that we talked about. So for example, a 1x32 splitter is about 17.5 dB of loss that we're going to budget for. So So as we are calculating our optical link budget, we need to factor in all the things in our environment, right? So at the bottom, we see a small table just showing a brief example. But we've got a 1x32 splitter. So again, that's a 17.5 dB loss on that splitter. And then in this example, we have 10 kilometers of fiber. So maybe we're going across a campus in this example. So at half a dB per kilometer, that's 5 dB of total loss that we need to accommodate for that fiber distance. And then if we add in all of our connectors and splices, right, splices being at 0.3 and connectors being at 0.75, We add all those up, we come to 3.6 dB of optical loss, and then we add them all up, and that comes up to 26.1 dB of optical loss. So then the big question, is that going to work? And the answer is yes. So if we look at the second bullet point here, the ITU G.984.2 standards for B plus optics, and I'll expand on that in a moment, those allow for 13 dB to 28 dB of attenuation. So we have a wide range of attenuation, far greater than we're used to with other network technologies. So that 26.1 dB falls nicely within the 13 and 28 dB of attenuation that's allowed. So that is a functional network. Now, that doesn't mean I should shoot for 26 dB of optical loss on every network, right? That one's got 10 kilometers of distance. So if I'm talking about a network within one single building, I should not have losses that high. And so that speaks to our designers knowing these things, right? They should understand what the budget should be. All right. So
some call connector. I'm sure you guys probably seen this.
Thanks, Anna. All right. So I would now like to introduce Scott McIsaac. He is our expert in testing. He has a lot of experience with that. So Scott, you want to introduce yourself and tell us about testing and troubleshooting and verification?
Thanks, Matt. Morning, everybody. My name is Scott McIsaac. I'm a technical account manager with Telabs, a member of the technology team here at APOLAN, and I'm going to take over the majority of this rest of this presentation. We'll talk about testing, troubleshooting, and verification, and everything that Matt just covered, how key and important that is moving forward. I'm trying to get that baseline for how do I want to progress with my testing, what the testing really means. So at what phase? Am I in the build phase of things where I'm just placing cable, splicing cable, starting to place the different passive equipment out there, the patch cables? Why would I test at different points? And then from an installation standpoint, starting to connect the electronics and doing that verification, am I getting that proper light source? So how does that fit with the budget that Matt just went over of 26 dB of loss? What did I launch at from an optical line terminal to my endpoint, which is an ONT or a work area outlet? Am I going to fall within that budget, and does it make sense? I don't want to just see random numbers for the sake of random numbers. I need to know that it fell within that range for a reason. And if not, then maybe it has to go back to that 80% issue that Matt talked about earlier, which was cleaning. Like he said, he doesn't always clean. Some people assume once you get a cord out of a bag and it's got dust caps on it, that the manufacturer built it and cleaned it before they shipped it to you. That's probably the worst thing that we can assume in these networks when we do testing, and as well as manufacturer equipment, the test sets that we use. How well are they calibrated? What do I have? There we go. Didn't seem to want to advance for me for a second. So, again, the key is, again, to verify the cable plant that you built, all that connectivity ahead of time so I can get that nice baseline that Matt was talking about. I've cleaned all my connections. I've tested all my equipment. We have things that are being placed that are very passive. And as the statement, the second bullet says, you're usually trouble-free. So these passive splitters should have labels on them from each manufacturer, and they should fall within a range based on industry standards. But that splitter may have a value of about a 13 dB of loss. I want to make sure that I'm not exceeding that. Could one or two fibers coming out of it have excessive loss to it? There may be a bad cable, a bad connector, or again, it's a dirty connector because that one wasn't specifically cleaned. Somebody may have only tested a few of the cables, and the next installer didn't do their cleaning before they installed it. I found in the past working at Verizon when we first got started with Fios, which was the predecessor to all this optical LAN that we do today. A lot of people just plugged things in and waited for the green lights to come on. And if the green light came on, they thought they were good. And they packed it all in and went home, and then it became a troubleshooting issue later on because we were taking excessive errors. It may have been because somebody didn't have a test set. Things were very costly in the beginning, and people didn't realize how important it was. So being aware of those kind of things, looking for the issues at those different connectors and jumpers, and being aware of, what's being disconnected and when. As I build a network and I test it in the component sections before I put electronics in, I can open up the network anywhere because there's nothing live in the network. But once I've created and added all the electronics, now I got to be very careful, based on that last bullet, about disconnecting the splitter from an OLT or optical line terminal port, because that one port could have 64 different users on that port. If it's a 1x or 2x 64-way split, if I'm doing XGS PON, or a 1x 32-way split if I'm doing GPON. So depending on what standards you're working with, you could have a ton of users on that connection. So disconnecting that that fiber before the splitter will take down that many out fibers that have customers on it. So really important, again, to do your pre-testing to make sure I've got a good quality physical network, which is considered to be the channel, end to end prior to any equipment being inserted or terminated. Once I've identified that, then I can move on to my next element of testing or installation. So some of the things we need to look at to be able to use for optical LAN testing and installations today. Whoops, how did I get ahead there? Did I skip a thing, or did somebody else move my back to there we go. Sorry, not sure how that jumped ahead. So we look at different types of test sets like OLTSs, PON power meters, OTDRs, or BFLs. There's different reasons for using different things. All right. So when I look at an OLTS or an optical loss test set, I'm taking a powered light source meter. There's multiple components to this. So I'm going to have two test sets. One is my launch light source and one is my receive light source. And then I have cables that I have to use in between. One of the cables is typically called like a null cable. It helps me zero out and calibrate my test sets so that I can account for that launch light source and not overpower the network. And I can get my actual distance and proper readings. Years ago, you had to use maybe standard fibers and something called a mandrel, where you were wrapping that fiber around this mandrel to try and zero out that light source so I could get a nice even launch, something I could measure consistently across. So all the manufacturers today have made improvements, and fiber technology's changed so much that I have physical null fiber jumpers that are set up for that process, so I can kind of get away from that mandrel testing and that much longer preparation. PON power meters, being able to test a light source once the OLT is already on. So I've got the OLT, I can see it at the very far end before I plug the ONT in and measure how much light do I have before the ONT gets connected. Does it fall within the proper range of that ONT's receive sensitivity and saturation? And when I mean sensitivity, how much light can the ONT actually see without going blind? Or the bare minimum light, I should say, versus the saturation. It's so much light. If it overpowers the ONT, it physically blinds it, and you may have to put a physical attenuator in its place to knock the signal down. So it's kind of like reading the newspaper outside on a sunny day. You typically wear sunglasses to attenuate the sunlight to make it much easier to read the paper. So same kind of concept there. The PON power meters come in a variety of standards as well, different manufacturers and different styles and different costs to go along with them. Some will be single port, some will be multi-port. Personally, from an installation standpoint, I like the multi-port, which allows you to put it in line with the OLT installed, so I can see the OLT and the ONT both firing light back at me. So the OLT is sending light down towards the ONT at a 1490 nanometer wavelength, and the ONT receives that light, and then it fires up ranges, and sends light back to me at 1310 nanometers. So that test set with 2 ports on it lets me put it in line between the two so I can see that the ONT is actually responding and sending light back to me. Becomes a pretty good device, as we talk about this a little bit later on, for proving that the light can travel in both directions. So unlike traditional networks that maybe some of you are used to in the past when you did SONET networks and other fiber networks, where you had separate fibers for transmit and a separate fiber for receive, PON networks or optical LAN networks are all based on a single fiber doing both duties. It transmit and receives over that same fiber, just different wavelengths going in different directions. So as we get into the physical testing, from our perspective, because you're using that fiber in 2 directions, bidirectional testing is the preferred choice. I need to make sure that that single fiber can do dual purpose. Is it a good transmit fiber and is it a good receive fiber? Can I send light back in the opposite direction? You know, Matt talked about the reflectance with APC type connectors versus your standard UPC type connectors. So if I get too much optical return loss because too much light's flashing back at me, it blinds the transmitter. Well, then that means that transmitter can't send all its light to the far end. The OLT would never be able to read what the ONT is sending back. So any of your video on demand commands are going back on that 1310 wavelength. Your voice is going back on that 1310 wavelength. If it's not strong enough to make it through the network because it's being blinded, then the OLT can't respond to it and your network's going to fail. So cleaning and testing, absolutely critical to try and do in both directions, especially from that initial test of your network. Test that entire channel end to end. And this is when we want to use that optical light test set, the OLTF. 2 physical test sets, a null cable, and then your tested jumpers, your known good jumpers that you're going to use throughout your entire test. You're going to create spreadsheets, get a nice test scale on every fiber, every connector within that network, and then that is what the different manufacturers will be able to warranty that physical network that you built for that specific project. You know, in some situations, single direction testing is acceptable. If testing in one direction, then typically the OLTS light source is going to be located at your head end or wherever the physical optical line terminal would be located. Again, and then the power meter would be at the workstation and wherever that work area outlet might be. For optical LAN networks, it's critical to test the wavelengths that are physically going to be used. So again, you might be migrating from SONET networks, DWDM networks. Everybody had their favorite channels you're going to use based on what the fiber is being used for and what types of transmissions you're doing. In the PON world, when I'm doing GPON, I'm doing 1490 transmitting towards the customer's device, and I'm doing 1310 back towards the head end. When I'm doing XGS PON or 10 gig PON, I'm doing 1577 and 1270. So it's critical to test those physical wavelengths to make sure that your transmissions are going to work before you put all your equipment in place, because we don't want to start taking people out of service in this network. So as I mentioned, channel testing, that's the terminology that the industry likes to use, is a recommended method prior to connecting active equipment. So I'm testing everywhere from the OLT prior to connecting a fiber jumper to that PON port. I'm going to include the fiber jumper in my test, but it's not connected to the OLT. I'm physically connecting to my OLTS test sets. I'm launching my optical signals from that test set out to the far end. I'm going through every splitter, every connector, all the way to the far end. And as long as I come up with that range, that budget that I need to be in, then I should be good. I may want to go back, test every connection in between. So every passive device, which means the splitters, the connectors, every patch cord that you're using, sectionalize it, test out the components so I know what my estimated budget loss was based on doing the math that Matt covered with you. Here's what's the expected loss over a kilometer of cable. Here's what the expected loss of a splitter is. Here's the expected loss of a physical connector. So I have a basic budget or guess estimate of where I should be. Then I need an actual measurement to go against it to make sure I don't need to go back and fix things. There's micro bends. Maybe I didn't have bend and sensitive fiber. Maybe we're trying to reuse some existing fiber that's in that network. Maybe there's some splices that I'm not aware of. So that's where the OTDR would come into effect. So an optical time domain reflectometer or reflect meter, depending on what part of the country you're from, being able to identify where those different values are, where those splices might be, where the unknown micro or macro bend might be. So having OTDRs today that are splitter aware so that I can test in both directions or back towards the head end is very beneficial. But again, you may be at the mercy of what do I have available to me today, and you can make the most of that test set with the known values ahead of time. So again, critical, test the network before you complete your installations, get a good warranty with it, and then the installers can just do nice, quick, easy tests to make sure I still have good levels, my electronics are doing what they're supposed to be doing. All right, so as we mentioned, passive link testing should be performed when full channel is not available during a certification. Manufacturers will award those warranties based on channel testing reports. So that's the baseline that you're giving the customers at the end to guarantee their network's a good network. I can grow from my GPON into XGS PON and hopefully into the next generation as industry standards start to develop and get adopted by the customers for different services. Right? Channel can also be used, be verified during the installation process, which means now I've put on the OLT and the ONTs. So when I reach that install of a physical ONT, the ONT is now powering up, it's lighting up, it's giving me good green lights. I've done my physical testing. I can go in and look at the PON management system itself. Some people might know it as the EMS. So I physically go into that manufacturer's equipment of the OLT and I look and see what does the ONT read. So within that, the GUI screens, I can physically pull up on that pane of glass and see that the ONT sees light. It gives me a light level reading. Is it going to be 100% the most accurate test? Nope, but it gives you a great reference point to say, I'm in range, I see light, as long as I'm not taking any errors, and it'll actually give you some, error values as well if need be. Then if I'm getting really erroneous readings, now I can start breaking the network apart and do my troubleshooting at that point. But that's when I need the other test sets to kind of go along with this. So depending on how your installation crew's set up, maybe you only have one technician that is the key person that goes out and does all the major troubleshooting, but every installer can connect anything up from beginning to endpoint and do a quick scan of the network using the PON management system and say, yep, I should be good to go. And then I can go back and do individual troubleshooting and use a PON power meter. Again, a single port, more cost effective to test from the OLT to the fiber jumper that plugs into the ONT. I got good light going in the ONT, but the ONT won't fire up, then it's most likely my ONT. If I have the 2-port, then I can prove the ONT's returning light well. Personal trouble I went out on years ago when we were doing FiOS, multiple times the installation crews went out and changed the ONT at the customer's house, thinking it was a bad ONT. Customer kept losing service. Couldn't figure out what it was. Then finally somebody went out with a PON power meter that had 2 ports on it, so I could put it in series with the entire network with the ONT live, and they were able to plug in and see that the ONT worked fine when it was the PON power meter right next to the ONT. I got good signal coming back from it. I could see it, verified it. Great, ONT's good. But then they went back in the network to where the splitters were and plugged in at that cabinet and saw that they weren't getting good light coming back from the ONT. So now they're able to sectionalize their network and say my trouble's from the splitter towards the ONT. Well, in this situation, it was a customer prem house. Again, could be a campus like Matt had mentioned. I'm trying to feed some distant building. So there might be an aerial drop wire or a buried cable somewhere. Come to find out, it was a bad drop wire from that manufacturer that wasn't allowing me to return light. So that physical single fiber was a great transmit fiber, but it was a lousy receive fiber in that situation. And I couldn't see it until I started breaking the network down and testing in the different locations. So that's when it comes critical to figure out how is your network built? Where are these different locations as we're trying to show here? So this is probably one of the more common scenarios that we see is a zone type scenario where I'm putting different terminals and connectors as far out towards the endpoints as possible, and then doing distributions from there. So I'm going to take measurements at appropriate wavelengths for my network. I'm going to document these and label that whole network scheme. And then again, I'm going to insert my light source, in this case at reference point 1, which happens to be the endpoint of the splitter prior to connecting the OLT and ONTs. Then I'm going to go test the output of that splitter to see, am I getting that loss that the splitter is designated for? Great, I've validated that splitter. I know I got a good splitter now. I can continue on my network, include my jumpers, leaving the splitter, going out to that LGX that's feeding a work area outlet or a zone box in the middle of my network somewhere, then get out to the zone box and start doing my testing on the endpoint of that zone box, that connector, that LGX at that location, and then the outputs of those locations before it goes to my ONT or work area outlet. Again, the more I can isolate and document, the better and easier it's going to be to troubleshoot down the line. So we mentioned this earlier as I'm taking my test sets. So now I'm looking at an example of an OLTS or an optical loss test set. Again, it's a combination of test sets. I have to have a light source and a light receiver, something to meter that. And then I need to have that good reference launch cord, which is that pre-tested null type cable so that I can zero out my meter. So I'm not extending or adding too much length into my network based on what the launch parameters of that original meter is. And then again, a good receive cord for that far end. So the two test sets are being set up right on top of each other. Again, get it zeroed, ready to go. And then I'm going to take that launch cord and I'm going to use that at every connector insertion point, and then my known good receiver cord at every receive point down the line. So you may be doing a lot of transferring back and forth, or it could end up being a two-person job to try and, speed up the process. One person doing the initial light sources sending, and the other one doing the receiving to be able to hit multiple ports. And then again, flip meters and do the opposite direction is the preferred method. So you've got a good transmit and receive fiber. Again, doing a passive link test with the work area outlet. Again, break down your components everywhere along the network, but this is before you've put any electronics on it. There's no OLT or optical line terminal, and there's no ONT within this network. I've proven my network, I've documented it, but now I'm good to start adding the OLT and the ONT, and then I'll have their physical light sources to be able to test end to end and compare against that budget that Matt talked about earlier. So this slide is just trying to show for any midpoint references or midpoint troubleshooting, I can verify first and then go back and troubleshoot at a later date if I need to. But once you've plugged a whole network up, you've done all that proper cleaning, if you're not doing moves, adds, and changes and unplugging fiber jumpers, you shouldn't have to go back to those locations and keep making changes, right? They don't get dirty on their own. Somebody had to unplug it. Something had to physically happen to that. It's pretty much a closed network. Once you've cleaned it and plugged those connectors in, you should be good to go, and it should stay fairly stable unless something major happened in that network. So now I have my moves, adds, and changes verification. And as we mentioned before, once I connect that OLT, that connection on the left-hand side here, that physical PON port is multiple customers or multiple devices being connected to that passive splitter. That single fiber input has a multiple fiber outputs. That means many users. So I don't want to disconnect this endpoint ever again because I'm going to knock down up to 64 different devices or users or endpoints in my testing. So it's critical, get my testing done ahead of time. I've got good known equipment. Then I can do my testing at my individual locations prior to entering my ONT. So seeing this 18 dBm on my power meter, giving my acceptable power range, neg 10 to neg 25, like Matt showed you before, my OLT might be launching at a +2, and it's got to receive sensitivity or bare minimum amount of light that it can see at, say, a neg 28. I don't want to be at that very end range of neg 28 if I can help it. Will it work? Yeah. Could you end up with bit errors? Possibly. So if I can be more in the middle range, it's ideal. Again, the shorter the network, the greater the possibility I'm going to have a lot more room to work with in this network. And we're coming right up onto that rough time of quarter to the hour. So I think this kind of gets us right about to where we want to be with questions. So is this being handed over to Chad again?
Yes, thank you. Thank you so much, Scott. Thank you, Matt, for a very informative presentation. We covered a lot of material there. Thank you very much. We have left a little bit of time for any questions. If anybody would like to ask anything about the presentation, if anything sparked anybody's interest, we'll give everybody a second to see what comes in. Okay, we did get a couple of questions. Let's see here. Do I always need to use a 1x32 splitter? Matt, maybe Matt, you want to answer that one?
Yeah, sure. Yeah, we certainly see that the 1x32 is the most common. And if we think about the optical budgets that I talked about earlier, you're going to need to at least introduce some amount of loss to get to the range that's required for GPON or the ITU standard, right? So you don't have to use a 1x32, but you do have to introduce at least enough loss to get to that 13 dB of loss. So it could be a 1x16, but then you're going to need to put an attenuator, or if you have enough distance between the OLT and ONTs, that could also introduce enough loss. But no, a 1x32 is not required, but probably by far what we see most used in the LAN environment.
Great, thank you, Matt. Scott, I think this probably fit with what you just went over. Why do I need to test fiber in both directions?
So like we mentioned before, because again, it's not the traditional network that you may have done in years past where it was a separate fiber for transmit and a separate fiber for receive. You physically tested both of those fibers in the past, but because we're using it as transmit and receive and having different wavelengths doing different functionalities, you really need to see what that optical return loss is going to be, what other tolerance they may be. As I mentioned, that trouble that we ran into years ago where it ended up being a bad drop wire. And the assumption to every technician was that it was a bad ONT, and they swapped the ONT out multiple times. And again, it was more than 3 different ONTs swapped, all because they didn't physically troubleshoot by testing the fiber optic cable and proving that it was a bad physical fiber jumper in that situation and not the electronic equipment. You know, there's many different variables in the network, so having the test sets are critical. You know, spending that little bit of money for the test set and having the key technician that's going to handle it because of your budgets, it's definitely a tool that needs to be part of that network to save a lot of rework. You know, 3 ONT replacements gets pretty costly on the operational side of things.
Great, thank you, Scott. We got another one, Matt, if you want to take this one. How to identify early damage for preventative measures on XPON networks? They're going to test you with that one.
Yeah, no, this is a good one. I think it's very relevant. You know, if the network is actively in use, I think the question is talking about that, right? How do you know whether maybe you have damage on the fiber or dirt on your connectors, those types of things? What's unique about GPON and XGS-PON and all PON networks is that the ONTs and OLTs have a power meter built into them, so we can actually see in real time on any given ONT what the power level looks like received from each one of those devices. So a number of the manufacturers even let you set thresholds where if the power level goes below a certain amount, it will alert you to that in real time about what's going on. So you can actually get real-time alerts from that. You can't use it for testing and certification, right? I don't want to make everybody think I'll just plug in the ONTs and if they work, then then the fiber is good, right? That's not the case. But for just what we're talking about, preventative measures, figuring out whether that fiber has a problem, maybe from somebody unplugging and plugging something back in, use the real-time power measurements from the ONT and OLT.
Yeah, great. Thank you, Matt. If anybody needs any clarification, just type it back in there, but thank you. We'll give this other one. We got a couple more minutes. Give each of you one more here, Matt. We'll just round it out with you. Is APC polish required for use in a PON?
Yeah, right. I kind of harped on the APC. It's not required to be used, but every ONT that we find on the market today has an APC connector on it. Conversely, every OLT actually has a UPC connector because the OLT doesn't launch at a high power level, so it doesn't require that APC. So we don't have to use APC throughout the network. We certainly have to match our polish type at the ONT, right? So it needs to be APC when it enters into the ONT. But if we're not carrying video, analog video, at that high power level, then no, we don't need to use APC throughout. So if you're working on an old network or I should say old fiber that's been around for years and doesn't have that APC connector, it's okay to utilize that fiber as long as you use your proper adaptive jumper cables, right, with a UPC on one end and APC on whatever connector is going into the ONT. That's perfectly fine, no problem there.
All right, thank you, Matt. And then Scott, we'll fill this last question, which I think is a good one. We all see and receive product, and they come with these little test strips in them. But are fiber jumpers clean from the factory? What do you say on that?
God, no. Oh my gosh. Again, when we got started doing this stuff back in 2003 from a FiOS perspective on a long BPON and GPON built network prior to optical LAN, cleaning was always such a question in everybody's mind. What was the proper method to use? And I still see so many different standards and ideas and thoughts to that, whether I do, cleat tops and dry method, or I do, wet then dry. Do I use alcohol? Do I use, some type of chemical? All the things that Matt covered, the residues and stuff were always the big concerns, whether I'm using alcohol or chemical, who has the best product. So I think there's constantly going to be validation out there as well that needs to be done from different perspectives to manage cost, time, and material. But you can't assume anything is clean. The dust cap's on to try and prevent it from getting more damage during shipping, from getting more scratched. But I think you could see from the scope slides that Matt showed, the amount of oil or scratches or damage that can happen. It's so easily to contaminate something. So even though it had a dust cap on it, let's say they did for some strange reason clean them all before they sent them out to you. Just taking that dust cap off, your fingertip touches it, you've contaminated the fiber. We used to do tests way back when where we'd take a fiber jumper and show it in class on a scope, and we'd throw it up on a projector so the whole class could see it. And you'd actually take the fiber jumper and wipe it across your forehead, which is probably one of the greasiest parts of your body, it seems at times. And you could see the oils running down the scope on the projector. It was just pretty amazing how quickly you could contaminate something, and then that cross-contamination that happens that Matt mentioned. So it's not just cleaning the jumper, but it's cleaning the port that you're putting the jumper into as well. So people think, oh, well, I can take a cleat top and just drag a jumper across it and I'm good. but now I plugged it into a patch cable panel that wasn't cleaned either. And we talked mated connectors. I got an APC on one side and a UPC on the other side. That 8-degree cut actually sticks out further than the UPC's connector, and they smash each other, and you end up with cracked connectors. So there's so many variables to this. But yeah, I've never come across a manufacturer to date, and I've been doing this for now coming up on 20 plus years of fiber connections, whether it's with the Sonnet world or into PON. I've never come across anybody that had good, clean fibers right out of a bag. So yeah, it's pretty important.
Yeah, those are always things, people try to slide by. Oh, it's got a test strip in this bag. It's good. We're good to go. So thank you, Scott.
In the old shirt cleaning method, I haven't seen anybody make a good shirt that I can clean a fiber jumper on yet either. Dust
My
free.
shirts are pretty clean, Scott.
Well, maybe you've got those dust lint free ones. I don't know.
No,
Let's put the black light
not a
down.
not a good method. Thank you, Scott. Thank you, Matt. We are out of time for questions. We want to thank everyone again. Thank you, Scott and Matt, for sharing your time and expertise. We encourage everyone to review APOLAN's association information highlighted on the screen in front of you and available on www.apolanglobal.org. Please visit the website. We have so much information there. We have tech forums, marketing information. Please join us in these forums and conversation. Go to the website. On behalf of everyone at APOLAN, thank you for joining us today. We look forward to seeing you again soon on another APOLAN webinar. Thank you, everyone.